everybody, and welcome to this video. In this video, we're having a look at mutually exclusive events. So what is a mutually exclusive event? It's two events that cannot happen at the same time. So we have the different ways of understanding it. So the first thing that we have, if we have a look at the diagram, is that these two events, A and B, there's absolutely no overlap between them. So there's no part where they both would be true. So in other words, the probability of A and B is equal to 0, and there is no intersection. So if you would like to find out if events are mutually exclusive, what you would need to do is check this property, that the probability of A and B must be equal to 0. So some examples of mutually exclusive events are the probability of you, let's say, getting a head on a coin and the probability of you getting a tail on a coin. If you flip a coin, it's either heads or tails. You can't get something like heads and tails. So if you flip a coin, you can't get a head and a tail. So these two events, getting a head and getting a tail on a coin, is mutually exclusive. Let us have a look at some examples. So it's quite a short exercise. And in this exercise, we have to calculate whether the following events are mutually exclusive. So let us have a look at the first case. So it says the probability of A is equal to 0.6, the probability of B is equal to 0.2, and the probability of A or B is equal to 0.5. Now remember, if we want to test if things are mutually exclusive, we have to check if the probability of A and B is 0 or not, right? So if we have a look at what we're given and remembering what we did last lecture, then we have that the probability of A or B is equal to probability of A plus the probability of B minus the probability of A and B. So this here we would have from the last video, and we'll just substitute each thing in. So the probability of A or B is 0.5, the probability of A is 0.6, the probability of B is 0.2, and then what we want to do is we solve for A and B. So we have 0.5, we'll take the 0.6 over, and the 0.3 over, they become minus 0.6 and minus 0.2, which gives us minus 0.3 is equal to minus A and B. So that means we get that the probability of A and B is positive 0.3, which is not equal to 0. So they are not mutually exclusive. They can happen at the same time. Okay, let's have a look at the next example. So again, we're given the probability of A and B. We're giving the probability of A or B. So we have that the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. So this is the relationship from the last video. Please watch that video if you are a bit confused. The probability of A or B is 0.9, the probability of A is 0.3, the probability of B is 0.6, and we want to know what is the intersection. So then we get 0.9 is equal to 0.9 minus probability A and B. And when we solve for the probability of A and B, the 0.9s cancel and we get 0. So that means that A and B are mutually exclusive in this case. So if we would like to test if something is mutually exclusive, we want to test that whether the probability of A and B is 0 or not, because that will help us tell if it's mutually exclusive. If there's an intersection, then it cannot be mutually exclusive because it means those two events can happen at the same time. But if there's no intersection, it means that they are mutually exclusive because those two events cannot happen at the same time. Please make sure you've understood this concept. It's quite important, and please watch our other videos on probability. Thank you for watching. Bye.